All right, everybody, we are on 12.3, which is solving subtraction equations. And this is basically just the opposite of what we did for solving addition equations. I'm going to go through a few with you, but I'm going to warn you that I'm teaching this rather quickly because I have seen many of you demonstrate mastery of this already. The equations will get harder as the assignment goes along, however. So when we look at x minus 2 equals 5, this is one that your brain can almost fill in. You can see what you would have had to start with for x in order to get it down to 5. I want to show you with this easy one what the numbers are doing and how to approach the problem. So one technique is to work backwards and adding 2 to both sides to find the original one. I had one student say, well, I just go, instead of going x minus 2 is 5, I do 5 plus 2 is x, because that is like, you know, those addition mountains. You have a 7, a 5, and a 2, and so you figured out the missing number. I think many of you are doing this quite young. So a lot of times in algebra you'll see x minus 2 plus 2 and a plus 2 on this side. Whatever you do to one side you do to the other because you're trying to get that naughty variable by itself. It can't be with any other numbers. It doesn't play well with them. We try to isolate it on one side. The way that I would suggest that you start moving toward is this. I had a really wonderful chemistry teacher who taught algebra quite well on the side, and he always had you do a layer where you do a plus 2 and a plus 2, and he showed a plus 2 is equal to a plus 2. You're doing nothing to the equation to make it unbalanced, and so what ends up happening is this zeroes out. 5 plus 2 is 7, x equals 7. So the key is to solve a subtraction equation, add the same number to both sides, isolate the variable. So let's try a couple now. If you mailed 5 postcards and now you have 9 left, what was your original number? So if you have to write the equation, which is a lot of times what they'll ask you to do, we don't know how many we started with, but we know once we took 5 away, we were going to have 9. X minus 5 equals 9. So I know if I'm going to take a little blue pen and I am going to plus 5, x is going to equal 9 plus 5, which is 14. So you need to be able to write the equation and then solve it, not just know in your head that it is 14. So this is q minus 7 equals 2. I'm going to have you solve it with the plus 7, and you get q by itself. It's all alone, equals 7 plus 2 is 9. Okay? I would like you to try to solve numbers 3 and 4 on your own, and then I will put the arithmetic up here. So pause me. All right. So in this case, we're going to add a 17 to this side. We're going to add a 17 to this side. This is going to zero out, so you're just going to have s. Should get 42 equals s, or s equals 42. And it's especially important when you have numbers like this that you do show your work. I want to see the process where you add the 2.1, and I know Mrs. Wilson is expecting this as well next year. The algebra teachers in the future are asking us to reinforce that you need to show these steps. And my son, who's at the U of M, said make sure they know how to do these steps and show them. So we get r by itself here, and we get the decimal point right here, 3. 5.3 equals r. Even if you can do this in your head, we want to see that you understand what you're doing to both sides, because mathematically you can't you can't add a 2.1 to this side without doing the same thing to this side. So this is all really that there is to teach on 12.3 subtraction equations. Shouldn't be too difficult. If you need any help at all, come and ask me. I think this will be a great assignment for really everyone. Have a good lesson.